All right, so we're going to continue with our circles unit, and today we're going to be looking at angle relationships in circles. All right, now I'm going to go ahead and tell you that this particular lesson can get a little um, troublesome. So I'm going to try my best to explain this as easily as I can so that it makes the most sense to you. Um, and so how I organize the notes is I've told you what kind of picture you're going to be looking for, and then the setup. Okay, and the setup will be how we set up our equations to solve. Because today is really a test of how good you are at solving equations. All right, so with angles, you have three different options as far as where the angle's at. The angle could be inside the circle, it could be on the circle, on its edge, or it can be outside the circle. And there are different setups for all of those problems, for all those situations. So we're going to look at all three cases. Um, and every case is going to have a couple examples. Some are going to be completely numeric, and then some are with an equation. So you'll be exposed to both. Okay. So the first one we're going to look at inside a circle. Oops, sorry, trying to fix that. Okay. So what you're looking for is you'll have a circle, and you'll have two chords intersecting inside the circle. You probably won't see them come outside the circle as much. You'll just see the inside part. So don't freak out too much if you don't see the outsides. They're most likely going to look like this. Okay. So you'll have two chords intersecting in. Oops, sorry. Two chords intersecting inside the circles. And when that happens, there's a special relationship. I'm going to get some colors so that we can help draw our eyes to what's going on. Okay? So, actually, I need two more colors. Okay. So, let's find how to write the measure of angle 1. So, angle 1 is right here. And what we'll do is, if you'll notice that angle 1, if you come straight off the side from it and you hit this chord of the circle, this part of the circle, so this part, okay? So these two, the red, or it's red, have mercy, the blue and the purple, they are the arcs that are intercepted with angle 1. They are going to be used by angle 1. So here's what we do. The measure of angle 1, we say, is half the measure of the blue arc, whose name is AD, plus the measure of the purple arc, whose name is BC. Okay? So it's kind of like the two pieces of the circle caught by the edges. You add those together and take half of it, and that'll be what angle 1 is. Okay? It's a similar with angle 2. So angle 2, instead of going this way, we would go up and down. And so angle 2 is going to use this one up here that I'm doing in red. That's kind of hard to see, so let me do it that way. So this one right here in red. And then it'll go with this one in green. Okay, so it's the same setup, so it's still half, but now you use the two that are opposite angle 2. So we would say the measure of AB arc plus the measure of arc CD. Okay? So that's your setup. When you see an inside angle problem, you match up the arcs that are opposite the angle. So either this way or this way. You add them up and then take half of it. Okay? So in a general roundabout sense, I tell myself that the angle is equal to 1/2 times arc 1 plus arc 2. I guess you could say, let's say it this way. Instead of arc 1 and arc 2, let's say it another way. Let's say big arc minus the small arc. Because generally speaking, one of the arcs is going to be bigger than the other one. Okay? So like for angle 1, arc AD is bigger than arc BC. So that we would put the big one first. Okay? So this is like the general case. And these are like specifics for this problem. So now let's look at how to use this. So find the measure indicated. So notice right here my question mark. I'm going to call him X. So I'm finding the angle here. And so I have to make sure that I know the arc this way and the arc this way. And I do. So this one is going to use this arc right here in blue. And then this one. You can kind of think about it as the X needs to use the arc across from it that way and this way. It's got to use both of them. That is a terrible arrow. Okay, now we set this up. So the angle, whatever the angle was called, we're calling him X, equals 1/2 times the bigger one. The big arc is 200 plus the small arc is 50. And so this one's easy enough that you can type all this into the calculator all at once, and you will get 125 degrees. Okay? You will see some problems on this kind of situation where the X will actually be one of these arcs inside. And so if that comes up later in the notes, I'll tell you what to do. But you could have one of the X's be inside here. And so the work would look a little different. Now, so that's a totally numeric example. This is an equation example. So we're going to solve for X. We notice it's a situation like this. And so we're going to use this kind of formula right here. So our angle that we were given, 10x plus 16, equals, now we're going to do 1/2 times the arcs. So our angle is right here. So we're going to go this way and use that arc. At 160. And then we'll come right behind it My purple's not working. And then we'll use this one. All right. And so we'll add the 160 plus 52. Now, on all these, on this situation, when you have this 1/2 in front, my trick is instead of taking half of this, we're going to get rid of the half and essentially just move it over here times 2. So to get rid of the half, we're going to double everybody on this left side to make our life easy. So double 10x gets 20x, and double 16 to get 32. And then that'll make the half go away, and you write whatever's left. And now, add those two together. You will get 212. Now we'll subtract 32. You will get 180, and then divide by 20. So x is 9. Okay, if you wanted to check yourself if you were right, plug the 9 back in. So 10 times 9 plus 16 equals 106. So what's supposed to happen is 1/2 times the big arc plus the small arc is supposed to equal 106. And when we plugged the 9 in, we got 106. So we know we did it right. All right, so that's inside. Now we're going to look at on. So on the circle, there's 2 different pictures. One picture looks like this. So you've got 2 chords intersecting at the same point on the circle. And so the measure of angle ACB, that's right here. Let me do another color. This angle right here. You're going to look at the arc, it's kind of like a huge pizza slice, if you will. So here's your angle that you're looking at. Let me do it this way. So here's the angle. And I tell myself which arc is caught between the angle. And it actually ends up being this angle right here. Or this arc right here, sorry. It's kind of like a weird pizza slice. This arc goes with the angle. It's called intercepted, okay? The way we write this is it's going to be 1/2 the measure of the arc AC. Okay? Now down here, looks a little different. So now we have a tangent line and a secant line intersecting at a point on the circle. And so we get this weird looking picture. So notice angle 1 is right here. I'm putting it in blue. It's the same idea as up here. What's between my 2 sides of the angle? Well, in this case, it's this arc right here. And I'm doing it in blue. So that blue arc is going to go with my angle 1. So what's the name of the blue arc? It goes from A to B. So we're going to say 1/2 the measure of arc AB. Now the other one, I'm doing in red. This angle 2, it's obviously a bigger angle. So which arc is caught between it? Well, it turns out it's the rest of the circle. Okay, so all that red piece of the circle is going to go with my arc. It's intercepted. And so we would say that is still 1/2 the measure. Now remember we talked about major arcs on Friday? This is a major arc. So I would call it ACB. B. So it's A, C, B. Okay? So notice the general format. No matter what the picture looks like, the angle is half the arc. So that's what I tell myself on these kind of problems. The angle is 1/2 the arc. 1/2 times arc, I should say. Okay? So let's look at some of these. So on this one, I gave you a numeric example of each picture and a equation example of each picture. But the work is still the same. So let me scoot that up just a little bit. So find the measure indicated. This time I'm looking for an arc, so I'm going to call it X. And notice that the arc runs this way. And so I tell myself, what am I caught between? Kind of like this. Somebody cut a pizza slice weird. So this arc, labeled X, is associated with the angle. And remember, we say that the angle measure, so here it's 85, equals 1/2 the arc measure, X. That's kind of how I set it up. So 85 is going to equal 1/2 X. Now how do we get rid of this? Double the other side. So X is going to equal 85 times 2, which is 170 degrees. Okay? Reversely, they could have had the X down here at the angle and given you the arc measure, in which case you would have X equals 1/2 times some number. And so you would just evaluate that. 1/2 times 170 or whatever. Okay. Same thing here. Let me pick a different color. My angle is caught between here. They tell me it's 58. I'm looking for X, the arc that goes with it. So it's the arc caught in between there. So it's the angle measure, 58, equals 1/2 the arc. So X. Remember, to get rid of the half, we're going to multiply the other side by 2. So 58 times 2 will give us 116 degrees. Okay. Sorry I keep messing with the camera. I'm OCD. Now, we have an equation. So again, our angle is right here. And so which part of the circle is caught in between there? It's this piece right here. And luckily they labeled it for us. That's nice. They told us 162. So we take the angle that we were given, set it equal to 1/2 times our arc measure of 162. Okay? Now, you could take half of this number. Just divide 162 by 2. But I get in the habit of doubling the other side. So we're going to double the 9, and we'll double the 6, X. So that'll give us 12X plus 18 equals 162. And I'm doing that for a reason, because there's some of these problems where moving the half, doubling the half on the other side is a lot easier than taking half of this. So just get in the habit of doing double than the other side. All right, now we'll subtract 18. So 12x is going to equal 144. And then we divide by 12. We should all know what this is. X ends up being 12. Okay? So solve for x. Here's my angle. Which piece of the circle is caught between there? It's this one. So we take the angle measure first, 86, set it equal to 1/2 times the arc measure, so 18x minus 8. So again, double the other side. 176 equals 18x minus 8. Now I'm going to add 8. It's not 176. My bad. It's 172 plus 8. So then I get 180 equals 18x. Divide 18. X is going to be 10. Okay? So far, it's not been too bad. So we've done inside the circle, we've done on the circle. Now we're going to look at when they're outside the circle. And I will go ahead and tell you, of the 3 cases, the outside the circle case can be the trickiest because of how we set it up. So I'm going to go a little bit slower on these. I'll try to at least. Okay? With the outside case, there are 3 pictures you need to look for. Okay? So the angle point is always going to be outside the circle, and how you make it looks different. So you can make it with 2 secant lines, you can make it with 2 tangent lines, or a tangent line and a secant line. Either way, the general form over here is going to be exactly the same. So it looks very similar to the inside case, but it's a little different. So this time, if the angle's back here, which 2 pieces are caught between the angle? Well, we start with this one. And then we have this tiny one behind it. So we could say that the blue one is the big arc, and then the purple one is the small arc. And so we're going to write those out. So big arc would be the measure of arc CE, subtract the measure of arc BD, the small one. So notice instead of adding the 2, as we did on the inside, when it's the outside, we have to subtract them. Okay? So on this one, my angle is out here. This entire thing on this side, oops, that's the big arc. And then the other one in purple is the small arc. So we'll say 1/2 times the big one. So the big one is a major arc now, so that's going to be arc B, oops. The measure of arc BDC minus the purple one, which is a minor arc, so we just call him BC. So see the difference there? This is a major arc, means you have to go through D. This is a minor arc, so you go straight to C. And then finally, the angle's back here, so you start with the big arc first. And then the small one. So this is small. This is big. Same setup. So the big one is just B to D. So the measure of arc BD minus the measure of arc BC. And I need to rewrite that up here because I forgot to put measure. So it's measure of arc BC. Okay? So no matter what, look at the general setup. The angle equals 1/2 times. Now the first arc you write every time is supposed to be the big one. So it's the big arc minus the small arc. So you'll have to write this every time for an outside problem, no matter what the picture looks like. Okay, so let's look at some of these. Okay. So notice what they give you. You need to know you'll have to be given an angle outside and then the big arc and the little arc. You'll be finding either one of those three. So let's see what they gave us. They gave us the angle outside, the small angle, the small arc, and then the big arc. We're trying to find that, so that's going to be X. And so, the big arc, we're calling him X. We're trying to find him. Oops, my red decided to not work there. And then the small one back here, they told us was 47. And then the angle is 45. So here's what I'm going to do. I'm going to write it as it's the angle first, and then equal 1/2 times the big arc, which we called X, minus the small one. That was 47. So notice now X is inside. So I actually kind of need to solve this first. So get rid of the half with doubling. So 90 equals X minus 47. And then we can just add 47. So then X is going to equal 137 degrees. Okay? So another numeric example. This time we're finding the angle. So X is going to be over here now. So we'll call it X. Let's make sure we know everything. This one on the far outside is the big one. So this is big. You need to label it. And then this one, that's the small one. So our angle is X equals 1/2 times the big arc, 146, minus the small one of 66. Now, on this problem, because the X is on the left side and everybody else is on the right side, you can just simply type this into your calculator. You don't have to worry about doubling the other side. Okay, so when you type all that in the calculator, it ends up being 40 degrees. Okay, so now we have some equations. This equation's easy. This one is the tricky one. Now I'm going to show you what you do for the tricky one. This one should be relatively straightforward. Our angle is x plus 51. And then we have a big arc over here of 164. This is big. And then we have a 62 behind it. That's the small. And so we'll set it up. The angle measure comes first, so x plus 51 equals 1/2 times the big arc, 164, subtract the small one of 62. Now, instead of doing all this over here, we're going to get rid of the half first. So double everybody on the other side. So that will give us 2x plus 102 equals 164 minus 62. So I'm going to clean this right side up a little bit. And we actually end up being at 102. Now I'm going to subtract 102. Look at that. So I'm down to 2x equals 0. That scares kids for some reason. I don't know why. It is perfectly fine with this answer we're going to get. So we're going to divide by 2. So x is 0. X can be 0, okay? Don't be scared of that. And sometimes that happens. Sometimes it don't. Well, I don't know if it happens often, but x can even be negative. A variable does not stand for the actual angle measure most of the time. It helps you get to the actual measure. Okay, so in that instance, x was 0. Last one. So our angle measure was negative 10 plus 12x. We have a big arc over here caught between this side of Q and S. So that's big. And then this one right here, that's the small. So now pay attention to how I set this up, because now everybody is written with an X. So it looks different. So we start with the angle, negative 10 plus 12x equals 1/2 times the big arc, which is 46x, subtract. Now, you have to subtract this off because that's the small arc. When you're trying to subtract it, and especially when it's a two-term thing, like you have a negative 5 and a 27x, after this subtraction, you need to put a second set of parentheses. Okay? I know it looks weird, but it's because this is two terms. Okay? When this has more than one thing attached, written with it, what I mean by that, and I don't think I'm explaining this right. What I mean by that, if this just said 27x, then I wouldn't need the second set of parentheses. But because there's something else there, we have to use a set of parentheses. So we subtract correctly. So here's what we're going to do. We're going to recopy this thing. And then I'm going to distribute a negative here and a negative here. So that 5 will become positive, and the 27x is going to become negative. Okay? So I'm going to bring all that down again. And I'm going to clean up inside. So I'm going to combine the 46x with the negative 27x. That's 19x plus 5. And now, double the left side. So negative 20 plus 24x equals 19x plus 5. So I'm going to subtract my 19x. negative 20 equals, whoops, plus 5x equals 5, and then add 20, sorry. So then 5x equals 25, divide by 5, x equals 5. So, of the three cases, remember you have inside, on, and outside. The outside case is usually the trickiest, and it's because of this situation when you have to subtract the small arc and it has two things involved, two terms. So use this as a guide, especially when you're going on this kind of problem and this is a two-term expression. But that's it as far as angles inside of angle relationships and circles. So you will have to watch the video all the way through. We have a homework assignment. I think there's 24 problems, I think. Some are like this, as far as being just numbers, and some have equations in them. And I kind of separated it by the cases. So the first few are inside the circle, the next few are on the circle, and then the last ones are outside the circle. Please, please, please ask questions if you don't understand something, okay? I know that this particular content with circles can get kids confused. So if you don't know something or confused, please ask a question. Alrighty then, that's it.